Okay, I'm going to briefly talk about how to visualize stuff in cylindrical coordinates. So you're going to be given a surface or a volume or just a region. For example, we'll just do surface in cylindrical coordinates. And then we need to sketch it. This is a useful skill because our brains work in such that we see things better in pictures, right? Because when we're babies, we can see stuff, but we can't speak. So pictures and visualization is inbred into us. So let's just consider an example problem. Sketch the solid. Given by, let's say, r squared less than z less than 8 minus r squared. And r here, of course, is x squared plus y squared. But I think the smarter way to think about this is not with Cartesian. Just think about it as cylindrical. I'm going to give you a couple steps to do this. So first, I would draw this in the ZR plane. This isn't what we're asked to do because the ZR plane is not a solid, but it helps to visualize. Because again, it's a 1D situation. A 1D we understand very well. So on the x-axis, I'm going to put r, and on the y-axis, I'm going to put z, because this is where the functional relationships are. Z is a function of r. So first, I'm going to draw the x squared. That's the parabola. And then 8 minus r squared. That's the second one. You don't need to get fancy, like or quantitative. Like don't bother doing this on graph paper. Don't make it harder for yourself. Just a qualitative sketch is fine. So, and then if you just label these things, we'll put an 8 up here because that's when r equals 0. You plug r equals 0 there, you get 8. And to get that intersection point, we're just going to equate these things. So r squared, we'll set that equal to 8 minus r squared. So really what we have now is 2r squared equals 8, r equals 4. I mean, r squared equals 4 and r equals 2. Obviously, we discard the negative 2 because r is positive. So I'll just label that 2 here as well. And so really, and of course z, we also have the less than or equals. So I'm going to put some shading here. Shade based on less than or equals. Because that gives you the interior. Okay, so this is, I would say this part is the hardest part, and then there's a very simple way to do the next part. Okay, so the way we do in the next part is we just rotate by the theta range in 3D. Okay, so I'll just draw our axes that we want. So x, y, and z. And what I'll also do is I'll plot the region just in the x part. Maybe I'll just label a 2 here and an 8 here. And then what I'm going to do is I'm just going to rotate rotate a good point. So rotate a good point. So the theta range is just 0 to 2 pi. And because in this case theta does not appear. Remember our equations were r squared less than z less than 8 minus r squared. That means that all thetas are okay. Okay, so I'm just going to rotate this. Here's a good point, that intersection point. So I'm just going to rotate that around. And then what I'll just do for the other parts is I'll connect the top and bottom to, for example, the opposite point along that cylinder. So, I mean, it's not great visualization. It's always hard to draw stuff in 3D, but you kind of get the idea, right? Maybe I can add a couple of curves indicating that this is a curved surface. I mean, this part's kind of hard, but really you get the idea, right? It's kind of a UFO in this case. Another way to visualize is to just reflect the ZR plane for r less than 0. So for example, if we can quickly draw that, what I'm going to do is I'm just going to draw it, and I'm going to draw it on the other side too. Okay, so this will represent a horizontal cross section of the solid. So for me, and then you can just imagine rotating it. About the z-axis. And for me, actually, that would be good enough. I would be okay with this because I think this is a much simpler. I think there's less clutter than if you try to make this a solid without a computer program. A computer program can help you with the solid, like Mathematica or Maple. Okay, so I hope this helps. Visualization is a useful tool in anything you do. Thanks for watching.